Today we completed how to calculate the slope. How to calculate the slope. Nothing but we understand the slope is nothing but gradient, and gradient is nothing but first time we are derivating it and we are equating with the zero. Whatever value you are getting it, that's what the gradient. That's what the gradient. That program also we got chance to see it. And in the layman terminology, we struck with the dark illustration, and I want to come to the down position. I have to come means how we are going to put our steps. That steps is nothing but the gradient descent, what we are trying to say about it. I have one more activity is available to automate this process. I have to do the slope calculation, and I have to update the weights, and I have to calculate the mean square error. What is the error I have to calculate it? Actually, you did it. The calculation of the slopes and updating the weights, and again calculating the error what is available. But if I want to do recursively, I want to do it, let us say 20 times, I have to do forward propagation, backward propagation like that. Then I should have some kind of functions, right? We are trying to prepare that functions, we are preparing it. For that, we are taking the sample inputs. What are the sample inputs? 1, 2, 3 are the inputs we are taking. What are the weights we are taking? 0, 2, 1 are the weights. And what is the target value I am expecting? 0. This is the real value or it is the observed value. Real value or it is a observed value what I am expecting it. Now we are going for here calculating the slopes. First we are going for calculating the slope. This is the input data, this is the target, this is the weights. Then we are trying to calculate here predictions, we are trying to do it. Weight into input data dot sum, that is nothing but prediction. Prediction is equal to what we got? 7. From that, we are trying to calculate the error. 7 minus 0 is 7. That means error is equal to this much, we got it. Slope is equal to, we are following 2 into input data into error. Slope is equal to what? 2 into input data into error. So this is generally what we are going to take it. It's nothing but if I do the derivative of x square, that is 2x dx, we are going to get it, right? 2 into that input into the dx is nothing but error component. This is a generic equation. Mostly in our machine learning, we are going to follow to calculating the gradient, which is equal to our derivative. It's equal to our derivative. So slope we are calculating using this formula, 2 into input data into error. There is nothing but gradient we are calculating using this formula. I can say slope, or I can say this is equal to what? Gradient also. Now we got the gradient or slope is equal to this what we got it. Then we are trying to improve the model weights, we are improving it. We given the learning rate is equal to 0.01 because we should not take whatever slope is available directly, we should not subtract the slope. Because of one, the step size may be more. Because of step size is more, we miss the actual minimum point, we are going to miss it. That's what eta. Generally we used to say eta or we used to say alpha. Actually we take an alpha, I think. Okay, eta means, you know, right? This is what called as eta. Okay. Yeah. Anything is okay. Alpha, gamma, eta, whatever you put it. So now eta value, that is nothing but learning rate is equal to what is this? 0.01 we are taking and we are multiplying it. Then this is what the weights updated we got it. That means new weights we got it. With these new weights, again what you have to do? We have to calculate the predictions. Then we are calculating the predictions, then we are trying to see the error, we are trying to observe it. Now comparatively previous, error is decreased or not? First time we got what is the error? 7. Second time what we got? 5. If I do one more time, then what will happen? This error still it will be reduces. Got it? Shall we do this process first? Then we'll go for how to automate this one using the functions. So let us go and try to do this process first. Yeah, deep learning we are going it's going to work. Now let's try to do this process. Now what we are trying to put here, input. Input is equal to, first we have to import the numpy. So import numpy as np, we are importing it. Then input is equal to, we are saying as np dot, what is this? Array of the values. What are the values we have by seeing this diagram? 1, 2, 3. So we are trying to pass here 1, comma 2, comma 3 is the values. Now I want to see what are the input values now available at this point of time. These are the input values 1, 2, 3. Now we are trying to define here weights also. We are trying to define weights is equal to again np array. Then the values are available 0 to 1. So 0, comma 2, comma 1 we are trying to provide it. Now we see the weights whatever we defined is these are the weights what we defined. This is the weights. Now target value or it's a real value I can say the target value is equal to we are trying to define as 0. This is the target value what we are defining as 0. Now I have the input, I have the weights, I have the targets. Let us do the already people are aware of it forward propagation we are trying to do it. Forward propagation I can say first time we are trying to do it. Forward propagation first time we are trying to do it. So can you calculate the now predictions value? The prediction value is equal to whatever we have the input, that multiplied with what is this? Whatever we have the weights that we are trying to submit, that is nothing but what is our prediction value. The prediction value, if you go and try to observe here, this is what the prediction value, what we got? 7. Now I want to calculate here error. I want to calculate error is equal to whatever we have the prediction value minus whatever we have the target, that is equal to error. Now we got here error also. What is this? 7, because our target value is what? 0. There is a common formula is available for calculating the slope. Slope is equal to, we are saying as 2 into the input data whatever available into, we are going to say whatever error is available. Error is a member of slope calculation. Remember, error is a member of slope calculation. That is a very important one. Now we are calculating the slope. It is also called as gradient. We can call it as. Now we have the slope also available in our hand. Now I want to update the weights. Let us try to update. Then weights, we are trying to update it. So updating weights. So let us say, I can say this also first update weights. First time we are doing the updating, right? First update weights we are trying to read. The weights minus, we have to provide here one more thing, learning rate we have to provide. So let us go and try to provide here learning rate. Generally learning rate will be, we are going to take 0.01. The positive values people are taking is 0.1 or 0.01 or 0.001 or 0.3 or 0.03 or 0.0003. These are the most probably what I got chance to see people are taking it. Okay, so we don't know which value is correct one. That is the reason we'll go for hyperparameter tuning. Will go in the hyperparameter tuning. We come to understand which learning rate is the best learning rate. We come to understand. Time being weights minus whatever we have here learning rate. Whatever we have here learning rate. We are trying to take a learning rate into what is the slope available. The slope we are trying to take it. Okay, if you want the slope here, whatever available, let's try to print it and also observe it so that we'll get the more clarity. Let's say slope. What is slope we have got? 14, 28, 42 we got it. If I go and try to observe here, learning rate into slope means learning rate is how much? 0.0. 0.01 into 14 is how much? 0.14. 0.14. What is the actual weights are available with you? First one weights is what? 0. 0 minus 0.14 is how much? Minus 0.14. So now we are going to get here minus 0.14. We are going to get it actually. Let us observe invalid syntax. Maybe it is not accepting number in the first place. Number name should not be start with the number. So now we given a minus 0.14 we got. This is what updated weights we have it. Now once we have the updated weights with you, then we can do the second forward propagation or not. Second forward operation with new what is this weights what we have it. Second forward propagation we are doing with new weights we are trying to do it. Okay, as part of this one, now again we have to do what? We have to do the prediction. We have to do it. The prediction is equal to whatever we have the input never changes, and we weights will be changing here. The weights is first time whenever we update the weights, that weights we are trying to take it. Dot, then we are trying to take here, sum we are trying to take it, and we are seeing here what is the prediction value. What is the prediction value? 5.04. Now, if you see the errors is equal to whatever we have the predictions minus whatever we have the target. Now we are going to get here error is equal to what is the error we got? 5.04 we got the error. Comparatively previous, the error is decreased or not? Like this only if I continue for maybe 20 times or 10 times or whatever it is, there is a possibility to get my error 0 or not. If you are getting error is equal to 0, that means what? If you are getting error is equal to 0, that means what? If I am getting error is equal to 0, that means what? Yeah, my model is perfect model, right? My model is perfect model. Okay, let us go and try to do that one 20 times. I want to do it now. 20 times, is it possible for you to do one by one like this? One by one like this? No, not possible. So now I am thinking like, can you write some program? What we are doing activities here, one is slope we are calculating. Based on the slope, next what we are calculating? Error we are calculating. Then each time we are trying to do what? New weights we are updating. This all story we are doing. Right? Same thing we are doing using the three functions we are trying to calculate same. Let's try to observe this one, making multiple updates to the weights. One we are trying to do here, getting the error. Getting the error. To get the error, we know everyone how to get the error by calculating the predictions we have to calculate. Then we have to calculate what? Error. Next is what? Based on this error, we can calculate what? Slope we can calculate it. We are trying to calculate here, slope we are calculating. Once I know error, then I can calculate slope. Now, if I have that one, I can calculate what is my mean square error. Instead of going for plain error, it is always better to go for RMSE value, root mean square error, or we can go for the mean square error. Any one is okay. So as of now, we are going for mean square error. We are trying to get it. First, we are getting the error, whatever available. That means this functional output we are taking here. Then we are calculating mean square error. This loop, how many times we are running? 20 times we are running. We keep on calculating the slope. The slope we are passing as input, and we are updating the weights, whatever available. Then we are trying to calculate here MSE, and MSE we are trying to store here. MSE we are trying to store here. And finally, we are observing on graph also, we are observing like this. What is that graph? I will explain later. First, did you understand how to calculate the error function? Whatever you are doing regularly, those things only be included in the here. Let us try to write the functions to automate above process. Write functions to automate above process. So we are writing functions to automate the above process, whatever we are doing manually. First, what is your goal? Calculating error. So error required. What are the things it required? Input is required. So next is what? weights is required. Next is what? Target is required. These three things are available. I can calculate the error. Now I need to calculate here what is the prediction I have to calculate it. My prediction is nothing but whatever we have the input that is multiplied with the weights whatever we have it. Then we are trying to do the sum we are doing. Then we are going to calculate here error. Error is equal to whatever prediction value is available minus whatever target value is available. Then we are trying to return whatever we got the error component we are trying to define. Is it clear? Now use above error and calculate slope. Calculate what? Slope, or you can also say what is this? Gradient. Try to calculate it. Use above error and calculate slope or gradient. So now we are trying to define here function get what is this? Slope. We are trying to get it. Again, this also needed same inputs required. Input we needed. Next what? Weights required. Next what? Target is needed. So now we are trying to pass here. If I first what I want here, if I want to calculate the slope means I need the error I required. Error I will get from where? From above function we are going to get the error. This function we have to call it, right? So I am taking this function and we are trying to call here, then I'll get the error. Once I got the error, what is the formula I said? Time being 2 into what is this? Input into what is this? Error. This is what the formula to calculate the slope we are saying, and we are trying to return here whatever we have the slope, we are trying to return the slope, we are trying to return it. Are you getting my point? So that's
one small doubt, sir.
Yeah.
You have taken slope is equal to 2 into input into error, right? This may change varying on the expression, right?
Okay, mostly it works. 90% of the problems is going to work. Okay, non-linearity, whatever we need here that we are going to introduce here. Okay, even we are going to see the back propagation. We are going to see it better than this one. How we can do it? Actual mathematics. We'll try to understand. Time being, it is a x squared derivation. Partial differentiation. Okay, that's what we are taking. Now let us move on to the next one. Use above error and calculate MSE, mean square error. I want it based on this error whatever we have it. I want to calculate mean square error. So define. Then we are saying as get MSE value. Again, this also needed here. The same three parameters are needed. One is input. Second is weights. Third is what? Target. Now inside this one, we are trying. This line is common, so we are trying to take this line as is. We are trying to get here error. Once you have the error, I want here MSE means mean square error, right? So NP dot. Then we are trying to take as mean square of the error. So we are trying to take an error power 2. That's what the MSE that we are trying to return here. That as a return MSE we are trying to return it. That's it. So we need the mean square error. We define. Okay, now we are in good shape. We have a function to calculate the error. We have a function to calculate the slope. We have the function to calculate the mean square error. Mean square error is somewhat more accurate than the regular error what we calculate. That's what we are going for. Mean square error. Now this backward and forward, I want to do it for 20 times. I want to do it. First, what I am doing? Forward we are moving. Then we are calculating the error. Based on the error, we are calculating slope. Using the slope, what we are doing? Weights are updating. Again, we are doing what? Forward propagation. Again, we are calculating error. Based on the error, we are calculating what? Slope. Based on the slope, we are updating what? Weights. Again, we are doing what? Forward propagation. That like that, forward, backward. I want to do 20 times. I want to do it. That's where we are trying to do here. Let us say forward and backward 20 times run it. We are running how many times? 20 times. I want to run forward and backward, forward and backward. For that, number of iterations is equal to number of iterations is equal to how many iterations? 20. Input has no change, input already there. Weights has no change, initial weights, we are not changing that one. Targets also no change. Input, weights and targets are having no changes. Okay. Now we are going to run for 20 times, we want to run it, right? Number of iterations is equal to, instead of putting like this, I can say directly write the for loop.
Whatever we have written
For I in range of, then I am saying what? 20. That means what? How many times I want to run this for loop? 20 times I want to run this for loop.
the above things are forward propagation.
Above things are doing both actually, forward as well as backward, both it is doing. Yeah, slope is calculated, that's okay.
We calculate slope. Okay, where exactly the backward propagation?
Backward here, weights updating, we are going to do the loop.
But not the above statement is not.
In an above statements, nowhere we are updating the weights. That is useful only calculate error, slope, and MS. That's it. That subtracting the weights, we are going to in this program. We are going to do it now. Now I want to do here MSC. MSC values also I want it. As of now, MSC values we are trying to create here. Empty list we are trying to create here. Empty list because each iteration I want to capture the MSC value. Now first time we are running, sir. High value is 0. High value is what? 0. First time we are running it. What you supposed to do now? First you have to calculate the error with the given input, with the given weights, with the given target. You have to calculate the error. So you have to call the function or not? You have to call the function. So error is equal to, we have to call this function whatever we have it. What is the function here? Get the error, we are calling it. Now I am passing here. Now we got the error, we got it. Once we got the error, what is the next we have to do? Using the error, we have to calculate what? Slope I have to calculate it. So we can go for the slope also, you can go for it. Are you getting my point? Using this error, I can calculate what? Slope I can calculate it. Or directly you can say slope also you can say. Directly you can calculate what? Slope also you can calculate it here. Let us say not required error. Directly we are going for what? Slope. Slope is equal to, we are saying. Why? Because slope is internally calling what? If I say get slope, internally calls what? Error it is calling, right? Get error it is calling. Get error it is calling and try to calculate what? Slope it is going to calculate it. If I have the slope with me, then what you can do? New weights are going to do it, right? So weights is equal to, now we are going to say weights minus whatever we have the learning rate into whatever we have the slope. Now I am going to get the new weights or not? New weights. Now what is the MSC here? The MSC is equal to, what is the MSC we have? MSC dot append will take it. Append how to calculate MS? Get MSC, right? So we are trying to get here MSC based on the inputs, based on the weights, based on the targets. We are trying to get here. We are calling that function inside this. Is it clear now? How many times this program will run? 20 times. How many errors I am capturing? 20 errors I am capturing. 20 errors I am capturing. Each time I am updating the weights or not? I am updating the each time weights are updating and keep on we are looping this one. Anyone has any problem in this one?
Can you add print statement, sir?
Sorry?
Can you add print statement?
Yes, we'll do that. We'll do that. We'll do that. So we'll
Also,
add
prints
here.
have to be
Okay,
updated
print.
after appending the first
Yeah, one
MSC.
moment. the number of iteration is, then I am writing it so that we come to understand how many times it is iterating. And the slope we are going to print here, let's say print, then say slope is then we are trying to say comma, then slope we are trying to capture. Then I want to see the weights also, I want to see it. So let's say print, then we are saying as weights, whatever we have it, the weights are comma, then we are saying as weights. And also we are looking for MSC. So print, then MSC, then we are trying to get the MSC, we are trying to get it. The weights is comma, right? Comma, okay. Now I am trying to execute this thread. Now you can notice, yeah, one moment. The number of iteration is what? 0. That means what? First time. What is slope is 14, 28, 40. This is what I did manually before starting my programming, right? Before starting my programming, manually I written line by line. That's what the weights what we got it. If you see above somewhere, yeah, here what is this? 14, 28, 42. Now we are trying to do using our functions. We are trying to do it. Next, what is the weights? Minus 0.14172, 0.58. Then what is the MSC at this point of time? Mean square error 25. Then we are going for the number of iteration is what? 1. That means second time it is. Then this is for the slope what we have and weights and mean square error. Now what is the mean square error? Wow, great. It is reduced or not? 25 to 13 it is reduced. Then next is what? The number of iteration is 2. The mean square error 13 to what? Where it is decreased? 6. Finally, if you go like this, in the last one is 19th will be there. 19th iteration. In the 19th iteration, you can notice here, slope is this the slope and weights are this one. MSC is what it is MSC? E power minus 0.5. That means e power minus 0.5 means how much, sir? 0.0000096. What is the number that one? 27. That's how the number. Almost it is 0, right? Wow, great job. Almost it is 0. That means what? We did a great job. Error is 0. So this is what the forward, backward we are doing, and what we are updating overall here? Weights are updating it. We know only inputs, we know only outputs. I don't know weights. Weights randomly I assumed it. I assumed randomly some weights I assumed it. Then I calculate the error. The error we backward propagated. Then we update the weights. Then we are moving forward. Backward, forward, backward, forward. This one we went it. Got it? If you understand this mathematical calculation, whatever I did here programming, then we'll go for somewhat deep dive into the backward propagation. Purely mathematics differentiations wise, if I am going means how it looks like, we'll try to observe. Is it clear now? Any questions, folks?
Yes, sir. A question, sir.
Yeah.
So could you please explain the updating the weight part?
Updating the weight part.
Right.
Okay.
Yes, sir. That formula.
This is okay. You understand how to calculate a slope, right?
Yes, sir. That's a standard formula, right?
Right.
Because
Now
that was something new.
Right. Directly, if I subtract the slope, there is a problem. We may miss our the step may be big step. Directly, if I subtract the slope, what happens? The step may be very big step. Because of the big step, I may miss the minimal point. To stop that one, we are trying to multiply with a small value. We are multiplying it. 0.01 into 14 is how much? 0.14. That 0.14 is a small part we are trying to subtract from the weights. So learning rate has its own side effects also. If I take the learning rate very small, I am taking. then more times we need to iterate it to get the accuracy. If I give the bigger value, the side effect is we may lose the minimal point.
Understood. Okay.
So generally,
So ideally, it's
Yeah.
0.1. 0.01 is the ideal one.
these are the ideal ones, whatever I given. Out of these things, which is the best value for our data, we are going to do the hyperparameter tuning.
Okay. Okay, that makes sense.
Yeah. Now, okay, this is what I want to cover about the forward and backward propagation. Just try to see this programming. That's what
So
in this slide what we have.
Before you change, sir, that a small observation from the root mean square. So we see that it's sort of dividing by 2, sir. Don't you think so? Like from 25 to 13, 13 to 6, 6 to 3, 3 to 1.
Which one? Which one?
So those values, the slope.
Slope, okay.
Yeah. I'm sorry, sir. When you see the result, can you go down, sir?
Okay.
Let me more down to the results. Down, scroll down a little bit more.
Okay.
So if you see from 25, there. From 25 MSE, it's gone to 13. From 13, it's gone to 6. From 6 to 3, 3 to 1.
Right. These errors.
Don't you see it's like more like dividing by 2?
No, it's not dividing by 2.
Roughly 2, 2 point, or 1.98, something like that, right?
Okay.
Don't you see that?
Yes, if you say like that, then 0 point. This is if you see at 0 point, it is 0001. It is last two things you observe it.
Last two
0.0018 it is available, right?
Yes, sir.
Then next is available at e power minus 5 means 0. 0. Yeah, maybe it's following that kind of pattern, but
yes, it is.
That indication is not there. Okay, that kind of rule is not there in this data. It's following maybe that kind of pattern is following.
So it's not because of the weights we found it, because the learning rate. Yeah.
No, not like that. Okay, if you want, you can change the learning rate and you can try it. If you that is what the question. Then let me change the learning rate. It is not based on the learning rate exactly. Let me change it. 0.0.
We can also check it for 10 iterations.
Okay.
Yeah, if you want 10 iterations, okay, let's take it. Then we are trying to check it out. Now we'll observe the last 4.54. It is 1.16. Okay, then it is a 445 divided with the 3 is coming 1.
Oh, yes, 11 threes are 33. Yeah, 3 point something. Yes, sir.
3 point something. Yeah, that means it's not closely.
It's based on the learning rate then.
No, it's not that closely, but there is some dependency. We are seeing it, right?
Yes,
okay. Anyhow,
so
whatever way it is decreasing, we are least bothered till we get the error is equal to 0. We'll be moving on it.
So that's the case, right? We started with 2.4, meaning if we will like manually we could calculate which learning rate to apply to come up. So right now we put 10. So after 10 iterations we got 1.16. So if we know that beforehand, right, we don't have to put 10. We can reduce it to 5.2 to save some time, right? Since we know error rate is reducing by 3 or 2. You know what I'm trying to say? It's just an observation.
Right. I got your question, but
okay.
But what I am trying to say is here it is only for one input and one output you are doing this calculation. So your calculations are working. What is my initial diagram? This is a diagram, right? In this one, only one input. That means one person information only taken. This may one may be salary, 2 may be education, 3 may be where he is staying it. And we are trying to say 0 is nothing but is a bank balance status. Suppose this is a one person information I have taken, but generally we are going to take 30,000 informations we are going to take and we are going to run the model. 30 or 40,000. Then it may not go in that whatever way simple mathematics is available. Okay,
You can
anyhow.
scale and just a thought, sir. It's fine, no problem.
Yeah, that pattern is following
Thanks,
in this
sir.
case. Okay, there is a dependency is there. Otherwise, the learning rate, these are learning rates only why to use it, right?
Right.
Now
So
let us.
small note, sir.
Yeah, one moment. Let us see this graph once. Now, if you see this graph, what is the problem? MSc history is not different. Okay, I given MSc, I think. Now, if you see this graph, what happened? The first few things fully dropped out. Whenever it is coming as a flatten, where it started, almost it is flattening. After one iteration, only immediately it is going as flattening. I think 1 to 2 we have some difference. But if you see carefully, from the 2 to 8, there is no much decrease in the error, right? We can break up this one up to 2 itself, because I noticed after 2 there is no much reduce in the error. Wherever there is no much reduce in the error, stop your program there only. For that we have the patience is the one parameter is available. Patience is equal, if I given 2 means, then it is going to verify last 2 times is going to verify is it any major differences came or not. If major differences not came in last 2 iterations, it is going to break the program. There is one parameters available, we are going to introduce it. So really, even though I given here 10 times iteration, it is a static programming error, and there is reason 10 times it is done it. Tomorrow, once I start applying my functions, inbuilt Keras TensorFlow functions I am applying means it won't run for the 10 times. It will, based on the patience parameter, it will observe where to stop it. Am I clear? Okay. So just try to refer it. I'll give few minutes of time. I will give it. Just try to refer it. Then we'll move on to the next one.